Hello, hope you're doing good. My name is Pranava and in this video I am solving a little different room called as Event Horizon. It's not a typical capture the root flag or capture the user flag or break into some security protocols kind of room. It's something related to analyzing what went wrong or analyzing what just happened in a network or in a system, what was executed. It's basically an analysis room or a forensic analysis room that we are solving here. It's called as Event Horizon, and it's pretty good. Pretty, they've categorized it under hard, and it says 120 minutes. But I did not feel that kind of difficulty in this room, so I thought let's showcase it here. I already finished solving this room. Uh, and we have a bunch of questions that we need to be answering along as we go towards finishing this room. So let's go with the description of this room and start solving this room here. It says Event Horizon, unearth the secrets beyond the event horizon. If I'm right, event horizon is the region of that black hole, which is, we don't know what exactly is there after that. That's what I understood from Interstellar. So, description: join Tom and Dom on a quest to find out what happens when you look beyond the event horizon, a quest beyond borders. They need you to utilize all your abilities to find the secrets that were taken when they crossed over the other side. And they've given us some task files to solve through, which is nothing but the zip file. So I will save this zip file in my usual folder under TryHackMe for YouTube. Create a directory here called as Event Horizon and press enter. I will save this zip file in this folder. That has saved the zip file there, and this is nothing but rest all the information that if you're using a attacker box, or it's better to use your own virtual machine and not to use any host machine for analyzing any such contents. So going to the answer the questions below, we'll just read the first question and get a hint of what to do and what to go forward. It says the attacker was able to find the correct pair of credentials for the email services. What were they? Format is email and the password. What they're talking here is about finding some correct pairs of credentials from the email services, which means that there was some email communication happening back and forth. Let's open our terminal here and browse to the location where we saved our zip file that we downloaded. Here we see the zip file. So I will unzip this evidence and that case number file. We see two files to be present, which is traffic.pcap.png, pcap.ng and PowerShell DMP. DMP is basically Windows's process snapshot log file or something like that. I'm not exactly sure, but it's something similar to it. So listing out the contents, we have PowerShell DMP file and traffic pcap.ng file. So traffic pcap.ng file is a traffic's log. Any communication that happens in a network, we can capture it through Wireshark and get an output called as pcap.ng file. So for that to analyze, we'll use our Wireshark tool itself. So I'll click on open, and this has selected the event horizon itself. Let's click on the traffic pcap.png file and click on open. There it shows us the pcap files contents, which is the network log, what was happening between the network communication. We see a lot of contents here. Now they said that the attacker found the email services credentials from the log itself, right? So that's what they say. Or what was the wording exactly? The attacker was able to find the correct pairs of credential from the email service. Okay, that's what they mentioned, that the credentials were found from the email services. Now if the attacker found a service such as SMTP, which runs the email services, they would have used a network and we would have found in this event log. So what we can do here is search for SMTP, and we get the entire log of SMTP that is present in this network log, and we can see the entire communication happening from connecting and sending a hello request to the email service to saying goodbye by ending the entire email communication here. Also, along with it, we can see something called as who's the user and a gibberish term here, along with a password and another gibberish term. What we can do is we can right click on it and go to follow TCP stream. They've asked us to find the credentials of the email services what was used in the format of email and the password. Now looking at this, we can say yes, this is the username that was used and this was the password that was used. But again, if I reset the room, we will be able to see that looks a little different. Okay, what if I do that? What if I reset the entire room? That would be fun, I hope. Reset progress. You will keep your points, but all your answers in this room will be erased. That's fine because we are solving it once again. So room has been reset. Okay, we see the format is a little different. Even then, if I don't look at the format there, by just an experienced guess, looking at this, I can say it's a base 64 encoded character, right? So following along this instinct, what I can do is open up cyberchef.org, which is a popular tool used for encrypting or encoding and decoding contents what we give into here with multiple operations that is possible. So I'll paste in the input that I captured from the Wireshark log, and then come here to say base. More than that, I'll say from base 64, drag it and drop it here. We get the email or the username of this service what we need to log in with. So we get that, we'll put it in here, and we also get the password. So let's copy that. I don't know, for some reason CyberChef started to post their ads. That's bad. Okay, we get also the password here. That's good. It's in this format. Paste it. It says, wow, correct. Your answer is correct. Now, the second question is, what was the body of the email that was sent by the attacker? So, attacker sent some contents to the user recipient. Okay, the attacker is Tom then. Okay, Tom sent Dom something in this email. So, what is it? It says somewhere here. This is the content. So, this is the email part. Till here it's all the email contents, the signatures. I don't know, I don't see any certificates and signatures here, but usually emails will be having those information. And here starts the content of the body here. It says, Tom, I have done it. I have found the mass of the black hole we found. Run the script as an administrator, your best friend Dom. Looking at the text, we see there's something sketchy about it. So we'll click on submit. What command initiated the malicious script download? Oh, that's interesting. So they say, I mean, is it Dom? Yeah, Dom says to Tom, saying that I've done it. I've found the mass of the block we found. Run the script as an administrator. I don't see any direct script anywhere. But looking at the content, we see it's an attachment and it says event horizon.ps1. Oh, that's a PowerShell script then. So that is also encrypted or encoded in the format of base 64. How do I know it? This content and the ending equals to sign, which is a sign of it being a base 64 encoded text. We'll copy that too, then run it through the base 64 and decoding from CyberChef. And looking at the contents, going through all this, the constants and the solar mass, all those contents are there. But scrolling down, I see something which is used by attackers and not scientists. I guess, I don't know. Scientists might use, but it's something like IEX new object.net web client download string and the URL from where it should download. That's a command which we use in Windows PowerShell to be downloading any contents from the web as a file itself. So this file has been downloaded from there. That's what was our question here. What command initiated malicious script download? And that was the command which initiated the malicious scripts download. Submitting that gave us correct. What is the initial ASE key that is used for decrypting the C2 traffic? Oh, that's something big. What is the initial AES key that is used for decrypting the C2 traffic? Here, we don't get much information about what is this AES key or anything like that. Okay, but but we don't know what is this. What are they talking about, right? So what we can do here is, since they say that a file was downloaded, which is the radius.ps1 PowerShell script, and what command initiated the malicious script download, we get a hint that something was downloaded, right? And also, along with the scenario, it says that the attacker compromised the system. So somewhere in the log, we would have some clue to go forward. Let's remove this filter here and then go back to the network traffic. Now, scrolling down, assuming that it used HTTP method to download this radius dot PowerShell script from the website here, we could find that in our log here. So scrolling down, we can look for something which is related to HTTP. Do we find any? So let's scroll down, and here we go. We see the get request of the PowerShell script radius ps1. That's good. So let's right click and click on follow HTTP stream. And that's a huge chunk of, again, a gibberish language. So what this did is it just downloaded the entire content in a format of base64 encoding. How can I know that? It says from base64 string. That means it's downloading as an not ISO, IO compress with the memory stream which is there. Okay, it's also deflating the entire stream of base64 contents. So what I will do is I will copy this entire base64 string. Then where is the end of this? We see the equal to sign. That's usually the end of base64 encoding. So let me copy this content once again, assuming that this is the radius.ps1 script. Let's copy this base64, go back to our cyberchef and replace this content here. This is all, again, a worst compression or worst junk that we see here, but that is because it's deflated later by the contents here. So which means that we need to also inflate the content. So raw inflate, I get that option here, drag and drop it. So that does something, but that is still not of an use to us, right? It's still of something which we can't understand. But technically, this is the PowerShell script, right? That's the PowerShell script that we are dealing with here. That's what is called as radius.ps1. What we can do is, let's click on the download button here, save the output file. It says download.exe. Let's download that as radius.exe and click on OK. And let's download it right here in the YouTube directory, and then say event horizon, and then save it here, radius.exe. So we see the radius.exe file here. That's good. But what else can we do it? It says PowerShell script, but we got an exe file, right? So let's analyze what exactly this exe file is. Is it any popularly known executable or a malware or a thing which would compromise it? Let's look for some signatures. I can look for the MD5 sum of this radius.exe file and then search for it. Or even another better way is go to virustotal.com and drag and drop this file. That would also do our job. Let's click on choose file, then TryHackMe, YouTube, event horizon. Select this radius. Okay, there's a misspell in it. Radius.exe file that uploads the file and scans for any known potential signature of this exe file or the malware that was sent here. We see it's known as Covent. It's a Trojan. It was tagged by Microsoft, and some other information about it. So what was the question? I forgot totally. What is the initial AES key? Okay, I got it. So it says it's a Covent Covenant. Okay, I'm very bad pronouncing. Don't, please forgive me. So that's a malware there, and this was all where the security vendors had tagged this as a malicious thing, and some others had tagged it as not as a malicious thing. But going to the details section, we see that this is MD5 and all the signatures. This is the same MD5 signature of it. If you can compare it, it's the same signature. So we could have just copy pasted the MD5 hash also here. We see it's a Windows executable file, and it's a .NET executable contents. It also has .NET libraries in it. So that's what they say, which means that this exe file can be broken down and analyzed further because it's a .NET content. Like any other .NET applications can be analyzed in a similar way by using something which is already present in Visual Studio Code called as IL-Spy. It's a module that you can install into Visual Studio Code. Module or extension, I'm not sure. It's an extension. So it's an extension which you can install into your Visual Studio Code, IL-Spy, and then it basically decompiles. It's something like we use Ghidra for analyzing the C files or C executable files in Linux programs. So this is the one which is used for Windows analysis. Now again, whenever you are running a malware or a malware which is already popularly known by any such things, it's better to have a dedicated sandbox machine to analyze it. But then anyway, this is a Linux machine and I'm not going to be executing this exe file. It's okay to analyze in this machine. But again, it's just a general note that use a sandbox machine for analyzing such things. You can install this IL-Spy VS Code extension into your VS Code in your Kali Linux machine. And if that is installed, you can search for IL-Spy. That's already selected here because I'd used it. So IL-Spy pick assembly from the file system. So I'll click on that option and then browse the directory where I have got this exe file. Then open that assembly language. So what I'm doing here is, since I got to know this exe file is there, I wanted to look at what exactly does this exe file do. So hence I wanted to break it down by using some application. Ghidra will also do the job, but that's more into a deeper level of assembly languages, and this is more comfortable for us to look at in our eyes. So I'll open this file specifically, and inside this we have different modules and sections in it. We have references and modules that was used by this program to use. So going to this under execute, that's where it basically starts the program. Then it is pointed to grunt stager. It'll come here, and then it says execute the stager. So it's going to execute this function. So these are all the individual functions present in this exe file. Inside this, we see the main program of this executable file. It has its own variables given out by the VS Code here, but it's something similar to the base structure of what exactly this exe file is containing. So here we see the key which is used by this program. So that's the key here. Now you can get into analyzing this code here, but that will take a lot of time. So I want to cut short it and then present you with a key here. That's where we get the key. It's going to convert it from base64 string. Everything in this is just encoded in base64. This becomes our key. We don't have to decode it. I mean, we'll not even understand what we'll decode it. Oh, I just pressed the terminal here. Let's copy this and then pass that as our key to the TryHackMe page. Okay, so we get the correct answer. Now the next question is, what is the administrator NTLM hash that the attacker found? That's a crazy thing to find now. Why is because we just know that this is an exe file of a virus or a Trojan called as Covent. Okay, now I went on with a whole set of research into what this Trojan is. Has anyone talked about it in YouTube and all such things? But later I realized that there was an easy way of just solving this machine is by finding this GitHub repository called as Covent decryptor, which basically decrypts and showcases us the way how the Covent Trojan behaves and works. And then they've given us the detail here. It basically works in multiple stages. The first stage, or the stage zero, how they have presented here, is that the infected machine. So I'll just read through this content because I'm not remembering it out of my head right now. So it says the infected agent initiates an RSA session by transmitting a public key encrypted using the setup ASCII key, which is embedded in a malicious executable. Before sending it, it formats the text as described in the another page with the type set to 0. So what they mean is, before it actually executes the command, it infects the system, taking the RSA session keys and transmits it by sending uh, the contents and the executables from the system to the target session by encoding it with its own keys and sessions that is present here. And we are able to see that similar contents. If you go on searching about this, it says hello world and contents like that, which is going to be sent as a part of the communication from this file to the target or attacker's C2 command interface. Then stage one, the C2 transfer is with a session key. That's it shares a session key for the by the tool, encrypted with the RSA public key by subsequent communication. Then it goes to the stage one. The infected agent employs a setup ASE key to decrypt the message and leverages the RSA private key to decrypt the session key of. Okay, so that basically the infected agent uses that keys to decrypt the messages that was sent by the target server using the session key, or it decrypts the session key using the RSA private keys. Then afterwards, it encrypts 4 randomly generated bytes using the session key and transmits them. Then before sending it, it formats the text as described in that file with a type set to 1. So the stages are set here. So the state set to 0 and state set to 1 are pointers basically to saying what stage it currently is present in. It's set by the tool itself. So the C2 decrypts the 4 bytes using the session key, appends 4 traditional randomly generated bytes, and then transfers the resulting 8-byte data to the infected agent. And then comes the stage 2. The infected agent decrypts the 8 bits with the session key. Subsequently, it checks if the first 4 bytes matches the data that has previously been transmitted and proceeds transferring the last 4 bits back to the C2. Before sending it, it formats the text as described in that. They've given a description of how this works, but I'm just lazy to follow along. So, okay, with the type set to 2. Now, this goes way beyond even my capabilities to understand. I've not gone through so detail about analyzing what this tool actually does it. If anyone has done it, I would like to get in touch and understand about how this exactly works. But basically, what I understood from reading through all this contents and what exactly we are doing with this tool is that this exe file has some unique keys and different levels and stages that it compromises a victim. It initially takes their RSA keys and then encodes it with its own private keys and then shares it to the C2 commands. C2 server, C2 is command and control server, and then it downloads some other bits of information and that communication happens back and forth. Now, I have not got in great detail about it. I just understood how this works and how it compromises. So we'll read to the description of how exactly this tool and what we are doing with this tool here. That's what they've given here. It says it's composed of 2 utilities. The extract private key script. It retrieves the P and Q primes from the minidump file to construct an RSA private key by employing the public key modules. So the public key modules are this. The decrypt convent traffic with script consists of 3 commands: modulus, key, and decrypt. The first command extracts the modulus from the malware communication, while the second recovers the AES key used for encrypting the data traffic. And lastly, the third command decrypts the traffic. So what in general this does is it takes each of these components of the different stages and then decrypts us the messages to given to us. So if that's clear, we can go to what to do. What do we need? What do we need is the data traffic of the covenant covenant is extracted from a network capture and stored in a separate file. So that's the first part, which is the data traffic of the entire covenant extracted from the network capture file. So talking about the extracted file, we can go to the Wireshark. Let me close all these windows of Wireshark. I'll come back to Wireshark itself here. So let's remove this filter. And so according to the different stages, what they've communicated to us here, the first stage, it's basically communicates to the C2 transfer session key to it. That means in the network traffic, somewhere we can see a communication happening back and forth to the C2 server. So this is where it gets the exe file in the system, and then some communication happens there. And what else? It sends a get request. It sends to eus test.html. In this tool, can I find test.html? No, I don't find anything like that. Okay, it posts some data. That is interesting. So it is sending some data into the C2 server. That's what is described in the state 0, that transfers a session key, which means it's sending a post, or it is sending some information to it. That's a good lead to follow for us. So I'll right click on it and say follow the HTTP stream, and we get the entire session of it. So it says get us test.html. Again, that test.html was a part of its communication, and it does some communication. It says hello world information. That's what we see in this page here. It says HTML head title is set to hello world, and body also contains the hello world in it. That's the same communication that's happening. And then it sends some, I don't know what language that is, looks like base 64, but it sends a lot of data back and forth, and also posting some information from our system, or I guess it's sending a huge bunch of contents here. So we have this packet, and according to our prerequest, that's the first prerequisite that we need to have. We need to have the data traffic of the covenant is extracted from the network capture and stored in a separate file. So we will save this. Click on save as from the down here, and let's save this here as traffic.txt. So let's save that file. Then what do we need? The AES key, which is embedded in the state 0 binary employed at the beginning of the communication, and a mini dump file of the infected process. So again, the infected process, they have already provided us the evidence.zip file, which is our PowerShell.dmp file. That is our instances dump, infected process. Okay, with that, what we can do is we can clone this file here. Let's copy this URL and say git clone and paste in the URL to clone it. That's good. So I can go to this file here, listing out contents that we have. We can also see the usage here. It says Python 3. So Python 3 decrypt covenant traffic.py. Then first we need to get the modulus. So that's here, modulus. I hope the spelling is right. Modulus. Yes. Then -I. We need to specify the traffic file. We can go back to a folder back and say traffic.txt. Then the key. That's the key that we found from the Visual Studio Code, and the key is, this is the key right here. So we can copy the key. I'm sorry. Cannot edit. Okay, fine. Let's copy this and then paste it here. What else do we need? Let's go back to this page, and we need to say it's encrypted in what. So -T for base 64. -T base 64. I'm pressing enter. It says data parameter not found. Okay, that's because if I go back to the folder here and say cat or let me not cat, let me open Sublime Text and say traffic.txt file. It has all the other contents also in it. Now it requires only the information which is like present in I, and then this information, and moreover the contents of the hello world which is present here. So that's what is also described in this contents here, that it requires the just the contents of what is being transferred, not the other part of the code. So what we can do is we can filter that out using catch traffic.txt and then use or we can just use grep. That would be useful to us. Grep po. And for the filter, let me open up my notes to which I had already written the filter to this. Let's copy that one itself so that we can make it a little faster. Let me copy this, paste it in here, and I say grep. What I'm doing here is I'm saying I just want anything starting with the caret symbol says I'm starting with I is equal to then any content after the I. So it is going to print us the information of anything which is here. This is starting with the command I and then the raw content which is present in this. Also, or the pipe symbol says or. You can exclude anything before that. We want anything here. It's also going to be excluding the text hello world completely, and then anything after the hello world that comes in here is what is going to be printed to us. So it's going to take out any contents which is beyond or before and including the hello world itself. It's going to remove that and present it to us in data.txt here. Okay, it's a very simple error. What happened here is I've misspelled it with the hello world in it. I guess that was a typo in my notes. So let's come back in this and edit it right. So it says hello world, WORLD. I guess the L had come after the D while in my notes. So pressing enter, we can rewrite over the data.txt file. Now open Sublime data.txt. And yeah, we see more information to also be present there, which is a good sign again. Open this file and now say let's open that previous command itself of Python and press enter. Still says the same thing. Oh, not the traffic.txt. I'm sorry, I guess earlier it was fine, but whatever. Okay, so we need to say data.txt file and press enter, and we get the modulus of it. This is the entire code of the modulus. Let's copy this content. Let's copy this, then open a new thing and replace it here. It has a new line breakers in it. Let's modify that. Let's make everything as a single line, which is good. And then save this as mod.txt. Okay, that's the modulus that we need to find. So click on save and we have the modulus there. Then going back to the Firefox page, we need to retrieve the RSA private key from the minidump file of an infected Covent process. I'm sorry. So it says we need to use the extract private key.py file. So let's do that. So Python 3 private or extract private key.py file. Then we need to specify -i, then memory dump, which is our PowerShell DMP file. Then the M is going to be the modulus of the output that we found. So what I will do is specify -m, then dollar, so that I want to run the command mod.txt right here. I don't want to paste it there. So it's going to automatically paste it into that. Then I just want an output here. So I'll say output, go to the previous folder. Pressing enter, we got a pair of P and Q that were located, but no, they did not match the modulus. That's fine with us. That's okay. Next, what else do we need? We finish this process. Then it says recover the session key from the state 0 response to the covenant C2, which is employed to encrypt the network traffic. So we need to decrypt the file there. So Python 3 decrypt covenant traffic.py. Now we are passing in the key, then say -i, which is again our data.txt file. Then the key that we got, they've taken the dump of the key. No, that's the PowerShell key that we have. Let's copy that and put it under quotes. What else is here? Then base 64, and then we need to specify the key that we just generated now. So -t base 64, and then -r is to specify the location of the key there. It's called as priv key1.pem. Pressing enter, that should base 64 packet not found. Okay, for the base 64 file here, what we need to do is go back to Wireshark, and this content is present, but it's not alone here in the data.txt file. It also has other contents like the I and the rest of the information. But this base 64 alone contains the required information, which is used for decrypting the key here. This information, I will copy it and then open up my Sublime text, paste it in there. I'll rename this as base64.txt file. We need to have the base, let's cancel. We need to have the base64 file in here for now and decoding or getting the key from the traffic there. Again, since I'm not too much into this is a tricky step for me too. That's what made me push myself into learning more. So base64.txt file there, then press enter. We get the new key here. So this is the new key that was generated from the server that it was communicating with. So I'll just copy that key. Next, follow the next step from the Firefox page here. Now is to decrypt the communication back and forth. That's the same thing. We need to use the decrypt command there. So Python 3 decrypt covenant traffic.py, then specify decrypt, then -i, the traffic file. Again, that is going to be our data.txt file. Then go with -k, which is the new key that we have. Paste it there. And what else is the information? Next is -t for the text. So -t, then hex. Pressing enter, it just prints out all the information that the entire communication was containing there. All the encoded communication that we see here, it just decoded everything that was here, which is good to us. I guess this file is a little huge, so I will dump it into something called as output. Let's go back one folder and say output.txt. Press enter. Then open the output.txt from our Sublime text here. The top, we get all the information, says padding incorrect and decryption failed, response message 3, and some more information. It talks about the Windows system itself. It says this is the host name, this is the domain of the username is administrator, and information like that. For the NTLM hash that we wanted and we are searching from that time, we get it right there. So we can copy that, go back to our Firefox page and paste in the NTLM hash. With that, we find the administrator's NTLM hash too. Okay, next question is, what is the flag? This is a major thing. So we see this huge base64 encoded text. Can you see it in the right side of the screen? It has a huge set of encoded text. That's surprising. It's completely base64 encoded. What I will do is copy this, open a new tab, paste it in here. I'll remove all these unwanted characters. somewhere in between we have an option here. Okay, there's a break here. We'll also remove those breaks, remove this double quotes, come here, and then where does this start here? So it'll start from here. Let's remove that too. I don't want to join it. That is okay with it. So I also remove all these other contents which is present here. Remove all these and then delete. Okay, till the quotes, and then save this as flag.txt. Now again, I'm assuming that it contains a flag there. Since it's base64 encoded, I will open this file from my CyberChef. You can click on this and click on event horizon and then the location to it. So flag.txt, open. And what do we see here? Any interesting thing? No, it's still some gibberish. Okay, that's because we have raw inflate. Let's remove that. And it says PNG. So that's the magic bytes, or that's the byte which all the image files are going to be containing. So we get that here. It says PNG in it, which means we can also render an image. Let's drag it and drop it here. And there we go. We get the flag for our machine there. So let's type it in here. So it's flag above and underscore. Am I not supposed to say the flag out loud like this? I'm not sure. I'm just going to talk something random if that's the case. Horizon, then enter. Does that solve it? There we go. We solve this machine, and that's a good thing. Yeah, it was interesting. It was a little difficult. Again, that's why it's tagged as hard. But it's not that hard if you know Wireshark, and then you know how to analyze any exe files, and then go through that search hunt of a Trojan, and then how do you decrypt it, encrypt it. And luckily we found this. Again, I can understand it is because I have got some other information, but that's barely I have understood so much that I can explain it. But this step talks about how exactly this communication works. With that itself, we have decoded the contents here. That's how it has worked. Again, if there's someone who has more knowledge about it, please reach out to me. I would like to have a talk with you about how this exactly works. Other than that, that's it for this video. We have found this flag. Hope you enjoyed solving this room, and hope you learned something new out of this. If you did, hit on that like button, and also comment down below what did you learn new and how was your journey solving this room of TryHackMe. It's tagged under hard, but still it's easy once you learn how to do it, right? So comment down below if you found it interesting too. And if you're new to this channel, hit on that subscribe button. Do all the YouTube algorithm stuff, liking, sharing, subscribing, commenting, and everything that is possible with the YouTube algorithm. With that, I would like to end this video and say thank you all. Thank you all for watching this video. Hope we meet in the next week's room of TryHackMe that we are solving. So till then, stay happy, stay smiling. Bye bye. Thank you.